Welcome back. So in this session, I want to train a machine learning model for classification using decision trees. So I have already imported iris dataset, which I have split using train test split function. So first let's import decision tree from sklearn. Decision tree classifier is present in tree module of sklearn. Okay, so first let's make an object. Let's fit our training data. So the criterion used is Gini index, which we have already talked about, and we are not passing any max depth, which means the tree might be a big one and it might be prone to overfitting. So let's not worry about this right now. We can use another dataset in the next session and try and pass max depth as well. Okay, so for now, let's calculate the score. So I'm calculating my training score first. So my score comes out to be 1, right? Which means that I'm not making any training error. Which also means that each of my leaf is going to be a pure node, right? Since I'm not making any error, each of my leaf node is going to be pure. So this tree might be prone to overfitting. So if I check my testing score, 0.9736. So I'm getting a good testing score as well. Actually, iris dataset is a very simple dataset. It's actually not very hard to get a good score on this. Okay, so let's do one thing. Let's build a confusion matrix for this. First, I'll have to import it. Let's create confusion matrix for our training dataset. Okay, so this is my confusion matrix for the training dataset. This is y actual and this is the predicted values. So as we already know that each of the data point was labeled correctly because our score was 1. So we have only elements along our diagonal. Okay, so let me do the same for our testing data as well. Okay, so in total there is only one error, right, which also explains our score 0.9736. Okay, so now we have built a decision tree classifier which is able to predict, right, and we have already checked the scores. Now what we want to do is we actually want to have a look at our decision tree, how it looks, right? So we actually want to analyze the decision tree visually. So till now, each of the library that we have used, that is NumPy, Pandas, Matplotlib, sklearn, and so many other modules which we have used till now, all have been already installed into Anaconda, right? But to see my decision tree visually, I will be using two things which we will have to install, right? Which does not come pre-installed. Those are graphviz and py.plus. To install, you can use the following commands. You can Google it, you will easily be able to get it, but these are the commands. So you can use these commands to install. So if you are on Windows, you can run both these commands in your Anaconda prompt one by one, and both of these things will be installed. For Mac and Linux users, you can do the same thing in your terminal, right? Okay, so after graphviz and py.plus are installed, next you will have to import it into Jupyter Notebook. Okay, So to build a decision tree, I will be copying some code and pasting it over here. So this is the code that I'm talking about. What this will do is print the decision tree in my Jupyter notebook itself. So this is the decision tree for our iris problem, right? So as you can see, some of the properties that I have passed is field is equal to true, which has done nothing but just filled the color into my blocks. I have passed rounded is equal to true, that is it has made the blocks a bit rounded. Feature names, that is my iris dot feature names, sepal length, sepal width, petal length and petal width, those are my 4 features. And then my target name, that is setosa, versicolor and virginica, right? So this is the tree that I am getting, right? As we have already discussed, each of my leaf is going to be a pure node. So if I look at each of my leaf, so this is my leaf. Here this is a pure node 0034, only virginica class is there. Similarly, all my leaf nodes are going to be pure, right? And as I can see, 37 points belong to setosa, 34 belongs to versicolor and 41 belongs to virginica, right? So at this point, if I decide that I don't want to classify further, so it will be predicted virginica for each of the values, right? So in total there are 112 data points, right? So 112 data points in my training data. So for each of them, my model will be predicting virginica, right? If it does not classify any further, right? But after my first classification, that is on petal width less than equal to 0.8, each of my 37 points are separated out, right? So which means that for all of my setosa points, petal width is less than 0.8. So in future, if you encounter a flower who has petal width of less than 0.8, my model will be able to predict it very easily that it belongs to setosa, right? Gini index for this is going to be 0, right? Because we know for pure nodes, Gini index is 0. Because this is a pure node, so Gini index is 0. Similarly, all my versicolor and virginica points went into this block, right? Further, it was split on petal width again. Then most of my versicolor and virginica points separated out, right? So at this point, if it had to predict, it would be making errors on 4 data points, and here it would be making errors on 1 data point. That is, at this level, if we stopped, our total errors would have been 5, right? But since we did not pass any max depth, so it kept on classifying further, and eventually all of my leaf nodes came out to be pure nodes, which means there was no training error, and hence my decision tree was giving me a training score of 1, right? Okay. So if you want, instead of making a decision tree in my Jupyter notebook itself, you want to save it in your local machine, what you can do, you can save it in a PDF file. For that, I'll be copying a piece of code. So if I run this, a file named iris.pdf will be generated in your machine in the same folder as this Python notebook. So I hope it is now clear how you can use decision tree classifier to solve our classification problems. In the next session, I will take another dataset to demonstrate it further. Thank you.